Hi friends, welcome to Data Info. In this video, we will talk about normalization concepts. So basically, before we go into what is normalization and how we can do the normalization, let's understand few important points. So basically, in a database, we will store the data, right? We will store the data in a tabular format. So whenever you want to store the data in a database, you will store it in the tabular format. So it doesn't mean that we should have single table and we will dump everything under that particular single table. So basically what we will do in real time, we'll create the database. Then under that database, we'll create a list of tables based on the business requirement and the client requirement. Each and every table will have specific usage. For example, employee table will have employee information. Department table will have department related information. Customer table will have customer related information. So each and every specific table will belongs to some specific business. So based on the client requirement, we'll create the list of tables. So this entire process, for example, creating the database and creating the list of tables and creating the linkage or relationship between the tables, this entire process we can call as a database design. So this normalization is nothing but helping the process of designing phase. So normalization is the process of organizing the data in a database. Organizing the data means creating the tables only. Organizing the data means creating the tables only. How effectively you are creating these tables is nothing but normalization. In easy terms, the definition of normalization is normalization is the process of organizing the data in a database. Organizing the data is nothing but creating the tables and storing the data in effectively format. So let's go to the normalization now. So normalization definition we understand. Normalization is nothing but how effectively you are creating the tables. So, but why we need to talk about normalization? Why we need to create table effectively? So, to understand that particular question, we need to understand few things. So, for example, my manager came and gave one task that is, so he gave this particular data set. Basically, this is denormalized data. So, he asked me to normalize this data. This is my task. And first, I need to understand what I need to understand. There is no magic button to convert this denormalized data into normalized form. There is no shortcut. To convert data into normalized data, we have to follow few rules in a sequential manner. Few rules in a sequential manner we need to follow. Those rules we called it as a layers. We have different layers in normalization. Like level one, we called it as the first normal form, then second normal form, third normal form. This is level one, then level two, level three, etc. So we have different levels in normalization, starting with first normal form and so on. So, but most of the companies will do normalization till third level, means third normal form, they will do the normalization. In very rare cases, they will go behind third normal form. So, in this video, we will talk about third normal form only. So, let's start our task. So, this is our denormalized data set. We have to normalize this data set. So, we'll go to level one. That is nothing but first normal form. So let me copy the denormalized data set. On top of this denormalized data set, we have to apply first normal form rules. So in first normal form, we have two rules. The first one is every column must have single value. It is very straightforward one. Every column should have single value only. For example, each and every column should have single value only in that particular row. Order ID same. Okay, quantity also look fine till this particular record, but here I could see multiple values. But as per the first normal form, we should have single value only. So let me convert this record. So we have to split this record into two records. Why? Because we have two values. So let me split this record into two records because we have two values. Here two values, here also two values, here also two values. So let me remove that extra 4 because 4 above and 4 below looks good. Here prod 303 and 4. 3 above, 4 below. Two records. We are not losing any data. Here 0780 above, 850 below. So here also we are not losing any data. Then here classic trucks. Okay, classic cars. Then buses. Fine. So we are not losing any data, just we converted as per the first normal form, first rule. So now verify. Every column is having single value only. So first rule fine. We'll go to the second rule. Each row should be unique, either through single column or multiple column, and it is not mandatory to have a primary key. So it's not mandatory to have the primary key, but either with the help of single column or multiple column, each and every row should be unique. Okay, so let's find out the combination. We don't have any primary key and we don't have any single column also to make each and every row unique. Each and every row unique means this particular row should not repeat one more time. This particular row should not repeat one more time. So that is means unique record. Each and every record should repeat only once. So which combination is unique? So let me say, if you see this particular column, order number and product code, if you see, these two columns are making our each and every record unique. The combination of these two records are unique between the rows. All these are not repeating. Okay. Here the same value, but here product code is different. So this is also looks fine now. So two rules we satisfied. Every column is having single value. Okay. And each row is unique. Each row is unique with the help of multiple columns. In our case, multiple columns means order number and product code. So once we are done with these two rules, then I can say this particular data set is under first normal form. So now we converted this data into first normal form. This is all about first normal form. These are very straightforward only. And let me go to second normal form. The second level is second normal form. So what is second normal form is saying? Here also same like first normal form, we have couple of conditions or rules. So the first rule is must be in first normal form. That is expected because we have different levels. If I go to level 2, if I want to go to level 2, I already should be in level 1. So due to that reason, it must be in first normal form. So let me copy my first normal form data and I will paste it here. So I can say this data set is already in first normal form. Okay, this data set is in first normal form. Rule number 1 done. The data set is already in first normal form. So rule number 1 we satisfied. So let me go to condition number 2. Before going into condition number 2, so it is bit tricky to understand here. So before going into for a second rule, let me give you couple of background about candidate key. So what is candidate key? Candidate key is nothing but set of columns which uniquely identify a record. Combination of columns which defines unique record. For example, set of columns. Set of columns means here if you see these two columns are making my records unique, right? Order number. So candidate key is nothing but combination of, in my case, order number less order product code. Product code combination of these two is making my record unique. Combination of these two columns are making my records unique. So that is nothing but candidate key. combination of these two records are making unique, right? So that is nothing but candidate key. So that is what they are saying. Set of columns which uniquely identify records. Okay. So candidate key is nothing but combination of columns are making unique record. So this is my candidate key. I can say combination of these two are candidate key. And what is non-key columns? Non-key columns are not part of the candidate key. All these columns are not part of the candidate key. So these are non-key columns. So now we got the info about what is candidate key and what is non-key columns. Non-key columns are these. Candidate keys, candidate keys are product ID, product code, and order number. Okay. These are straightforward only. Now, what is candidate key and what is non-key column? Non-key columns are nothing but which are not part of the candidate keys. Okay, we got the info. Now we'll go to rule number 2 in second normal form. All non-key attributes must be fully dependent on candidate key. Okay. If a non-key column is a partially dependent on candidate key, then move them into separate table. Every table should have primary key and build the relationship between the tables should be formed by using the foreign key. So let me try to explain in easy way. So what they are saying, if any non-key column is not fully dependent on one of the candidate key, then move those columns into separate table. So example case, if I take these columns, if you see these columns, quantity, item price, and total cost, these are fully dependent on order number. These are explicitly belongs to this particular order number. For example, if I buy a t-shirt, for example, I went to Amazon, then I purchased one t-shirt. The t-shirt quantity, whether I purchase two or three t-shirts, that quantity and that particular cost and total cost and that order date is belongs to only that specific order. Okay. So these columns are fully dependent on order number. But if you see and if you go to product name and product price and product code, those are not fully dependent on order number, right? Because this particular product is purchased by Rajnikant and the same product is purchased by Srikanth or some other customer also. So it is not mandatory. This particular product is always under this particular order number. So this is partially dependent. These details are partially dependent. This particular product can be chosen by some other orders also. So, and also this particular order is fully dependent on this particular candidate key. Quantity is fully dependent on this particular product. No, right? The same quantity will be available. The same quantity will be available for some other product. If you see here, 4 is belongs to classic car and the same 4 will be belongs to some other product also. It is not fully, it is partially dependent on product code. But this 4 is fully dependent on this particular order number. And this 4 is fully dependent on this particular order number. But product code is not fully dependent on order name, order date, or total cost, or total price, or quantity. Same way, and customer also. I can choose shirt sometimes. I can purchase TV sometimes. I can purchase mobile sometimes. So this particular person also partially depended on order number. So as per the rule, if any columns are not fully dependent, then move those columns into separate tables. Let's move those columns into separate tables based on the category wise. So this belongs to one particular category. Okay, product is belongs to one more category. So whatever the columns are I am moving, those should be partially dependent on order ID and fully dependent on product code. Why? Because now I need to check this particular table is satisfying all the rules or not. Also, I need to check. So let me check. It is already in first normal form. Fine. Okay. Now let me check all the rules. Yeah. Is motorcycle is fully dependent on product code? Yes. This motorcycle I am identifying with the help of this particular product code. So I could see couple of duplicates. Those records are not needed because the data is repeated. 3 and 4 already available. So let me remove those extra records. Now each and every product is fully dependent on product code. Yeah, this looks fine. And the customer also same thing. Customer also partially dependent on order number. So let me move these columns to separate table. Fine. These details also I move to separate table. Let me check all the rules are satisfying here. So what they are saying, the table can have multiple candidate keys. Not this one. Let me go to our rule. Each and every separate tables. So if it is not fully dependent, then moving into separate table. Yeah, moving into separate table and check for duplicates. So this particular record is repeated. So let me delete this particular record, extra record. Now customer also move to different. Let me move this data to here. Okay, fine. Okay. Now the size details are related to this particular order only. So I will keep this sales info. Whether my sheet small or big or small or medium, those details are related to this particular order only. So I will keep this info. Or then what else? Second rule is satisfied. We splitted the tables. We splitted the tables if those columns are not fully dependent. Yeah, these columns are fully dependent on order number. Then product details also fully dependent on product code. Then what else? Customer tables info also separate table. Looks good. Second rule fine. Third rule is every table should have a primary key and form the relationship between the tables by using foreign key. So every table should have primary key, right? So for that reason, I will create primary key. Order number I cannot use because the data is repeated here. So order ID I will create order ID. This is my primary key. Order ID. So this one, what I will do is, yeah, this is my primary key. Here it is my primary key. Primary key. Fine. Orders fine. Product code I can use this column. Product code I can directly use this column. And customer name we don't have any primary key. So what I will do is I will create one customer ID. Customer ID. Here also 100, 101. Then same pattern to other record. I will use the same formatting. Yeah. Now three tables, three primary key columns. Fine. Now apart from primary key, what they are saying, establish the relationship. Establish the relationship. That is expected, right? Because end of the day, all this data is related data only. Yes, there is a subject different like orders, product, and customer. But end of the day, all these data are related data. So due to that reason, we have to create the relationship. So let me create the relationship. Here, what I will do is I will create the reference key here, product code. Then this particular product is same. 4 and 5 is repeated. So 4 and 5 here. Yeah. Mm, Now reference key is created here. This is reference key or foreign key. Product is good. Then customer also I need to copy. Customer also I need to copy. 105 actually repeated. We deleted duplicate data, right? So there we removed 4 and 5 from product and 5 from customer. Yeah. Now let me create the on the same catalog. Yeah. Product, same color. Okay. Customer also under yellow, light yellow. Now what I did, I created a primary key from every table for every table done. Okay. Then later what I did, I created a relationship between the tables. I created a relationship between the tables by using the foreign. I established the relationship. So all the three rules are satisfied. Let me cross check. Must be in first normal form. Yeah, this data is already in first normal form. Then go to second rule. Move the columns to separate tables if they are not fully dependent on one of the candidate key. We move this data into separate table. Why? This product is not fully dependent on order. This product is dependent on product code, but not on the order number. So due to that reason, we splitted this data. And same case to customer also. This customer data is fully dependent on customer ID. This land is belongs to 100 only. Always this particular customer is just like our employee ID. My ID always constant. With the help of that employee ID only, I will be recognized. Same case to this particular customer. This customer is identified with the help of this particular customer ID. So due to that reason, if they are not fully dependent on one of the candidate key, then we are moving that data into separate table. That part also done. Then third part is create primary key in each and every table. Yes, we created a primary key in each and every table. That is also done. Then next part is establish the relationship between the tables. So I established the relationship between the tables by using the foreign key concept. So this is my second normal form data. So let me go to third normal form. So what is third normal form? Must be in second normal form. So before coming into the third normal form, the data should be already in second normal form. So let me copy this second normalized data. Then we will convert into third normal form. So let me copy. Now, after copying, then I can say this data is in second normal form. This data is in second normal form. I can conclude that this data is in second normal form. So second rule is what? Avoid transitive dependency. What is transitive dependency? Let's say if you have a table T which is having three columns A, B, C. If A is functionally dependent on B and B functionally dependent on C, then we can say that A is functionally dependent on C. So let me try to explain what they are saying. For example, I have couple of columns. So let me go to normalized data. So product name, product ID is my A column, or else customer name will consider as a column. Order is my B column, and salesperson is my third column, that is C. Okay, now what I can say is C. Okay, fine. So what I can say is this particular customer is identified with, for example, if I know my customer name, so what I will do, I can find out all the relative orders related to this particular customer. If I know my name, then you can identify the orders which I placed, right? So I can say a is our major column. If you see here, the concept is I am identifying the orders with the help of customers. That is the requirement now. So if I know the customer name, I will get to know the orders which are related to that particular customer name. So I can say that B is functionally dependent on A. B is functionally dependent on A because if I know customer name, then the associated orders I will get to know. So B is functionally dependent on A. So that is one part. If I know my order, the associated salespersons also I will get to know, right? If I know my order, the linked salesperson also I will get to know. So now I can say B is functionally dependent on C is functionally dependent on B. A links to B and B links to C. So indirectly, if I know A, I will know about C also. That is what transitive dependency means. A, what they are saying here, if A is functionally dependent on B and B functionally dependent on C. So that is what we are seeing, that linkage. If I know A, then if I know A, I will get to know about B. If I know B, I will get to know about C. It directly means that A and C are functionally dependent. So that is what they are saying. So if A is functionally dependent on B and B is functionally dependent on C, then we can say that A is functionally dependent on C. So this particular data set is causing trans to dependency. Why? Because this particular B is functionally dependent on this particular sales information. So due to that reason, we have to move or we have to eliminate this trans to dependency column. And apart from these three columns, you don't see any trans to dependency. These columns are not trans to dependency. If you know quantity, you will not aware about the salesperson. If you because the same quantity will be used by multiple customers. So these columns are not a trans to dependency. Only these columns are causing the trans to dependency, and the other two columns are those are linkage columns, not the regular columns. These three are part of the regular columns, and these three are causing the trans to dependency. Apart from these three columns, you won't see any other column which is causing the trans to dependency, like A dependent on B, B dependent on C. That is not there in other columns. So let me eliminate these records and put it in the separate table. Third normal form is just about removing the trans to dependency. If you see any column which is causing the trans to dependency, then move that data into separate table. So that is what I am doing here. So here also I need to create one primary key, because before splitting only I need to satisfy till second normal form. So there are duplicates. I will eliminate this particular duplicate record and I will create the primary key here. I will use sales ID, sales person ID, salesperson, person ID, some numbers, A1, B1, C1. Okay. Then we have to create the linkage also, right? After splitting, the next part is creating the primary key, then creating the relationship. So due to that reason, what I will do is I will create the linkage also. I will create the linkage also here. Here my linkage. So F1 is repeated. If you see here, we deleted that extra record, right? So that F1 is repeated actually. So this is also reference key. This is also reference key. Let me put it in here. Now this is also foreign key. So we splitted the table and we created the primary key. Then after that we created the linkage also, means foreign key relation established. Now this particular data is in third normal form. We removed the trans to dependency and we created till second normal form. The data is already in second normal form and we remove the trans to dependency. So I can say this data is in third normal form. Okay, this data is in third normal form. But why we need to do till third normal form, or why we need to talk about this normal form means, if I don't do this normalization, you will see n number of issues. So if I go to denormalized data set, this is my denormalized data set, the data which you seen earlier. So if you see that multiple values in single column, so this is denormalized data set. So what will happen with this denormalized data set is we will see the data redundancy and data inconsistency or data integrity. So data redundancy is nothing but data anomalies. Data anomaly is nothing but data related issues or problems. Anomaly is nothing but problem. So what problems you will see with the denormalized data set means, suppose if I want to insert data into this particular table, so what I will do, simply I will insert one record, 90, some record I insert. But the problem with this insert is, if you see here, all this data is repeated. Every time whenever I will do insertion, this particular data is like repeated data. So if you see here, all this data are belongs to same customer, but we are repeating the data. So we are wasting our database space. So that is one part. Yes, I can use the insert statement. I can insert this particular data, but indirectly it is affecting our space we are wasting some space because there is a repeatance in the data. So if you see here, all these are repeated data. This is one of the reason. And one more reason in the insert only, you know only about the customer or product. Some new product is introduced and you want to store that data in table. So the product ID is PRD underscore 007. That is nothing but a shit. So new product came. So that product details I want to store. The problem is that is not part of any order. None of the customer is purchased that particular product because that is newly introduced. But other columns, what about other columns? We have to fill with what? Blank only or null. So we have to fill with blank. So if you see here, same like above record, you will see null values because this is new product. So we introduce this new product and I want to store that info in the table. So we stored that info, but other info is not available. So due to that reason, we are putting null. So this is one more issue. So these are related to insert. So we are wasting space and we are placing some unwanted data here. So unwanted data we are populating with null. So these are related to insert problems. So if I go to update, even in update also you will see similar kind of issue. So what is similar kind of issue means? Same concept here also. The data duplicates are there, right? The data is repeated. For example, this particular customer changed his address. So how many records I need to update? So many. So if I have, for example, this particular person placed 1,000 records, then data might be repeated 1,000 times, and those 1,000 records I need to update. All these records I need to update. So that is one more issue related to update. And third one is delete. So the same case, delete also same case. This particular person deleted his account from Amazon. He deleted or deactivated his account. So what we need to do? All these records we need to delete, right? All these records we need to delete, and we are losing this info also. Product related info we are losing, customer related info fine, but other info which we needed like product info we are losing. So update is difficult, delete also difficult, insert also difficult. So to avoid these issues, for example, if I want to update address of this particular person in normalized data, that is very easy. So for example, I want to update this particular person address. So what I will do, I will go to customer table. Just I need to update this particular record only this record, only this particular part I need to update, nothing else. Since this particular customer is associated with this particular record, so it will fetch always, it will fetch a right data only. There is no disturbance. We updated data in customer table, but it is linked to our orders. So we will fetch the latest data only. Even if this particular person is not available, what we will do? We will delete this particular record. Nothing else. There is no loss of data. We are not losing any products. We are not losing any orders. This particular value will be inactive. If we want to see any customer with 100, we won't see those details. But that is fine. We are not losing any products. We are not losing any other customer, or we are not losing any salesperson. But here, if I go here, here we are losing something. The product we are losing, the orders details we are doing. So this data we are losing. But after normalization, we are not losing anything. And if I want to update any customer details, simply I can delete the data. Simply I can update the data by going into that particular record, and I will update the required info only, not the entire duplicate data set. Here we are updating each and every record. I need to update all these records. All these records I need to update. But here only single record. Here only single record. Only this record is enough to update. So this is the advantages of normalization. So thank you for watching this video. This is lengthy video, but I covered most of the topics. So thank you for watching this video. Please subscribe my channel for more videos.